So I know we finished the lesson and that came to 15 minutes, but I just wanted to go over these last three on the following page just for extra practice because these concepts are rather involved. So this first one, number 6, I've already filled it out for us, but I'll just highlight what it is that they're emphasizing. This measure of this angle here, that circumscribed angle, x degrees, is equal to 180 minus this angle here, which again, you can think of that as the central angle, or we know the central angle has the same measure of that inside arc. So you can think of it as 180 minus the central angle or 180 minus that inner arc. Regardless, it's 120, so that's how we get 60 degrees is our answer. Okay, now, and there's a lot of connections and parallels. Like I've said in class, like everything in math coincides and connects. So if you're thinking like, I could draw some right triangles with things like this, because we love triangles, or if you're seeing other patterns and relationships, that's awesome and outstanding. And feel free to share them with me. I can share them out with the class. I just don't want to throw too much, like I said, to everyone. So, but I encourage those recognitions. So, all right, on this number 7, this one, again, using that, my options are it's intersecting outside. I can either do the outer arc minus the inner arc and take half of it, and that would work. Or I can say, well, in this case, what they're giving me is that we have this angle that intersects itself, that has an intersection point right on the circle. So if this is x, by our theorem, the arc that it intercepts is going to be 2x. Okay, so then, even though they don't give me the central angle, I could draw that in. If this arc is 2x, then that central angle is 2x as well. And that's where the theorem, this circumscribed angle is equal to 180 minus my central angle 2x. And that's, from there I subtracted 180 divided by -2, and I have 65 as my final answer. Okay, now here's another one of these Earth scenarios, and that's the one I kind of got cut off on. So here in this one, we're at the top of a mountain on a clear day. You're about 2.73 miles above sea level at point B. Find the measure of arc CD, that arc right there, and that represents the parts of the Earth that you can see. Okay, so what is the degree value of what you can see is what they're saying. So since we're about 2.73 miles above, and we know from before that the radius is about 4,000 miles for the Earth, so the radius is 4,000, that would mean this would be 4,000, but that extra 2.73 is how we get that segment BA has a length of 4,000, 2.73 miles. Okay, so I've drawn that triangle, just this triangle over here to the left. And again, this is not the only way to do it. There's another way where you use that theorem that the circumscribed angle theorem, but just pulling it all together, this is what we have here. So here's that right triangle, and I know it's a right triangle because they marked it with a right angle. So I have this right angle here. That's the radius of the Earth, 4,000. This is that distance from the center of the Earth to the top of the mountain where we're standing, 4,002.73 miles. So if I find this angle right in here, okay, so again, building it off of our image, this is this angle right here. That's half of my central angle. Okay, so the way I find that angle, if I'm finding an angle measure, I use inverse. That's why we have the inverse here. I'm given from angle A, I'm given the adjacent and the hypotenuse side. So adjacent and hypotenuse goes with SOHCAHTOA. It's going to be the cosine. Okay, so I have cosine inverse of my adjacent 4,000 over my hypotenuse 4,002.73. That equals this angle, the measure of angle A. Now the reason I use 3 letters is because it's only half of that, like A could be that whole thing, so it's a little, so we want to use 3 letters. So it's angle CAB, and that's what we're finding here. So we calculate that out. I get the measure of angle CAB is 2.12. So that means if I kind of think of this image here, down here, here is the radius of the Earth, here's the other radius of the Earth, here is the Earth itself. This angle right in here, half this piece, just half of that central angle is 2.12. That means this other one is 2.12 as well because they're congruent. And so then the measure of arc CD, the entire arc, which is what they're asking us to find, is 2.12 times 2, or 4.23. Now, I know that if you do 2.12 times 2, you don't get what I have, but This is rounded. When I calculate it in my calculator, I took the actual non-rounded answer. So the cosine inverse of 4,000 divided by 4,002.73. That actually gives me 2.116242.794. So with that being the case, if I double that number, that's where I get 4.23. If you wrote 4.24, I would not mark it wrong, but it's good practice to try to avoid rounding too soon. So even though I wrote 2.12 here on my calculator, I didn't erase it and only write 2.12. I kept that entire long decimal and just multiplied that by 2. So the actual answer. All right, that's a lot of stuff. We're gonna slow it down. Like I said, this chapter started out nice. Not that it's not now, but it starts to pick up, and we put all these theorems together, it can get a little bit much. So slow and steady wins the race. See me with any questions. Thanks, guys. Bye-bye.